All right, so let's take a look at this last problem. Again, we're working with function composition like we did in the previous problem. And again, I like to think of this function composition like an assembly line, you know. And the first thing to remember is that you start with the second function. You actually read this from right to left rather than left to right. So we're taking things from the domain and inputting it into G. And the output of G is now becoming the input into F, and then our final answer is here. Well, to be in the domain of this F composed with G, the number has to make it all the way through both functions. It has to go all the way through this assembly. And if there were, like I say, if there was another function, it would have to make it all the way through. You know, you can make this as long as you want, but for introduction purposes for us, we're just working with two functions. So to make it to the end, two things have to be true. That every time you have input into a function, it has to be in the domain of that function. X has to be in the domain of G because it's the input into this function. Well, G of X is the input into this function. So the output of G, and we give it this name G of X, has to be in the domain of F, or otherwise it won't go through this function. You won't produce an output. Okay? So both of these functions, G and F, are rational functions. I don't have any square roots to worry about. The only thing that I have to worry about is division by zero. When I look at the function G, I can plug in any real number you would like, except if you try to evaluate G at positive 1, you're going to get 2 divided by 0, and that's undefined. 1 minus 1 is going to give you a 0. That means that we want to throw 1 out of the domain. We do not want to allow X to ever equal 1, because like I say, you won't have an output to plug into F. All right. So now let's take a look at F and see what its domain is. Again, I don't see any radicals here. I do see a variable in the denominator. I have to avoid division by 0. So I know that F does not want it to ever see the value negative 2. Well, F is never seeing the original input. F is seeing the output of G. So this output of G, we want to avoid the output of G to ever be negative 2. If the output of G is equal to negative 2, then I make that joke that F starts screaming at G and says, what are you doing to me? Whatever number you just plugged in, don't do that. I can't work with the number negative 2. Negative 2 causes division by 0, and I can't produce an output if you give me a negative 2. So we have to figure out what value of X caused the output of G to be negative 2 and avoid that. So we temporarily come down here and say, okay, let's figure out, it's a puzzle, let's figure out what input X caused an output of negative 2. Well, if G of X is this 3x minus 1 over x minus 1, and that equals negative 2, let's solve this equation. Now remember, sometimes equations don't have a solution. This is a proportion, so let's take the cross product. Let's multiply along this diagonal, and let's multiply along this diagonal. So along the yellow diagonal there, when I multiply by 1, I just get the 3x minus 1 back. When I multiply this by negative 2, I have negative 2 times x minus 1. So I've got 3x minus 1, negative 2x plus 2. Let's add 2x to each side. Let's add 1 to each side. Let's divide by 5. So let's stop and think. Well, what did we just solve for? Why were we doing this? You know, sometimes it's easy to lose track in the middle of the problem and go, wait a minute, what was I doing? What did I walk in here for? G evaluated at 3 over 5 is equal to negative 2. That's what we just figured out. Well, that's what we do not want that to happen, because if we allow x to be 3/5, then when G does its arithmetic, it's going to produce an output of negative 2. And when F tries to do its arithmetic with negative 2, it can't, because it leads to division by 0. So we have to come in here and restrict the domain and say, don't use 3/5. And it's not, G doesn't have a problem with 3/5. It's F. It won't make it. Remember that both numbers have to make it all the way, all numbers have to make it all the way through this assembly line. They have to make it through each function. G didn't like 1, and F doesn't like negative 2, but we never, G doesn't have a problem with negative 2, and it's going to do, the output, if you have an input of negative 2, if you input negative 2 into G, you're going to get an output that's not negative 2. Look at what you're going to get 3 times negative 2 minus 1 over negative 2 minus 1, negative 7 over negative 7/3. Well, F doesn't have a problem with 7/3. F has a problem with negative 2. So that's why we're throwing out 3/5. We're not going to throw out negative 2. We never throw out this intermediate value is what I'm trying to stress. All right. Now we need to describe the domain. It's all real numbers except these two values. And maybe it would be smart to sketch it on a number line. So here's 3/5, which is smaller than the number 1, and all of these other values are okay to be in the domain. So to describe that set, how do we describe that set? Well, my domain of this composition is from negative infinity to 3/5, then or if you're between 3/5 and positive 1, or if you're bigger than positive 1. That's the domain for F composed with G, and we didn't even have to find the expression. We used the domain of F and the domain of G to find that answer. Let's take a look at this composition if it's in the other order. If it's G composed with F. Okay. So the first thing that has to be true is X has to be in the domain of F. Otherwise, you'll never have an output. This output now becomes the input for the next function, G. And if you want to have an output, this F of X has to be in, the output of F has to be in the domain of G. All right. When we look at F, what is its domain? We don't have any square roots to worry about. We do have a variable in the denominator. Negative 2 plus 2 is going to give you a 0 in the denominator. You need to avoid that. So we do not want to have negative 2 being in the domain of this function composition. Now, when we take a look at G, G doesn't like the value positive 1. If you try to input 1 into this function, the output's going to be undefined because you're going to have 2 divided by 0. All right? That 1 minus 1 is a 0. So the output of F, we want to avoid it equaling positive 1. All right? But in order to figure out what input caused that output, we have to temporarily let it equal to 1 and solve this equation. So if it were the fact, if F ever does produce an output of 1, G is going to start screaming, saying, I don't know what you did, but don't do that. You can never give me a value of 1 because it'll cause division by 0 and I can't produce an output. So let's figure out what input would cause an output of 1. Well, f is equal to x over x plus 2. And I'm going to write 1 as a fraction, 1 over 1. Now, remember that not every equation has a solution. This is a proportion. Let's cross multiply. So we have x is equal to x plus 2, but something's wrong here because when we subtract x from each side, 0 is not ever equal to 2. So this equation right here has no solution. I don't have anything to worry about. That means that there is no value in the domain. There is no value that we would ever plug into f that would ever produce an output of 1. G is always going to be happy. G will never see the value 1. So f of x is never going to be 1. And G smiles. G's happy. So whatever, the only thing, f is the only the problem that has with x equals -2. So that's our domain for this G composed with f is all real numbers except -2. The domain is all real numbers except -2. I hope that helps. Talk to you later.